Welcome to this deep dive. We're jumping straight into the real foundations of statistics today,
That's right.
specifically looking at those absolutely crucial first steps. How do we actually take raw numbers?
All that scattered information.
Exactly. And start to make some sense of it through collection and, well, organization.
Yeah, and our source material today gives a really clear look at those building blocks. We're talking definitions, practical examples.
Things that show how you turn that mess of data into something, well, understandable.
Precisely. The mission here is really to unpack these key ideas so you can see how raw numerical information starts its journey towards becoming, meaningful insight.
Okay, so let's unpack statistics itself first, because you hear that word, and it seems to have two main meanings.
It does, yeah. There's the singular sense first. Think of that as the whole field of study.
A discipline.
Exactly. The systematic method for dealing with numerical data.
Yeah.
So collecting it, yes, but also analyzing it, presenting it, interpreting it. It's the whole subject.
Got it. The methodology. And then the other meaning, the plural sense.
That's the data itself, the actual numbers, numerical facts that have been collected for some specific purpose.
Right. Like census data, or maybe tax figures.
Or even just student test scores, like in our examples, those collections of numbers gathered systematically. Those are statistics, plural. It's the raw material we work with.
Okay, so the data itself, those numerical facts, collected deliberately, like the example in the source, children's hikes, just the list, 153, 147, 150.
Yeah, just a string of figures. That's your raw data right after you've collected it.
And collection itself can happen in lots of ways, right? Surveys, government counts.
So absolutely. But the immediate challenge, once you have it, is that a long list of numbers like that is, well, practically useless on its own. You can't see anything in it.
This is where it starts getting really interesting, I think. The sources really stress that once collected, this raw data absolutely must be organized.
It's essential. And the main way to bring order to that initial chaos is through what's called tabulation.
Tabulation. So putting it in tables.
Basically, yes. Arranging the data systematically. Think about a list of student names and grades versus a table, maybe organized by class.
Oh, okay. The table immediately gives you clarity.
Instantly, you can see patterns, you can see summaries that you just completely miss in the raw list.
And speaking of seeing patterns,
Yeah.
once you have some structure, this idea of frequency pops up immediately.
Frequency, yeah. It's simple but really powerful. It's just a count.
A count of what?
How many times a specific value or, a piece of data appears in your set.
Okay.
So if you have data like 5, 7, 3, 8, 7, 5, 5, you just count. The value 5 appears, 4 times? Its frequency is 4.
And 7 appears 3 times, frequency 3.
Got it.
It tells you how common something is.
Exactly. It gives weight to the numbers.
Now, the sources also talk about organizing beyond just a basic table.
Yeah.
There's this distinction between raw data, that messy list, and arrayed data.
Right. Arrayed data is simply the raw data sorted.
Sorted how?
Either smallest to largest, that's ascending, or largest to smallest, descending. Seems basic, but just sorting it is a key first step.
Why is that so important?
Well, it helps you see the range immediately, maybe spot outliers, and it gets the data ready for more complex analysis later. It's foundational.
And this sorted arrayed data, that's the basis for making a frequency distribution table.
Yes, exactly. That table lists each unique value you found in the data.
Like each specific test score.
Uh-huh. And next to it, you put its frequency, how many students got a 4, how many got a 5, and so on. That's an ungrouped frequency distribution. Every value gets its own line.
Okay, ungrouped. But what if you have like tons of data where the numbers are really spread out, like
Right.
the example with 40 student marks from 12 all the way up to 59?
Right. An ungrouped table there would be huge, wouldn't it? Listing every single score.
Impractical.
Very. And that's where grouped frequency distribution comes in. You have to group the data.
How does that work?
You create class intervals like 10 to 20, then 20 to 30, 30 to 40, and so on.
Ah, ranges.
Exactly. And the table then shows the frequency, the count for each interval, not each individual score. It summarizes things.
So you lose a bit of detail, but you gain clarity. You know how many score between 10 and, well, usually just under 20, right? Because 20 often starts the next group.
That's typically how it works, yes. Those numbers defining the range, like 10 and 20, are called the class limits, lower and upper.
And then there's the class mark.
Right. To represent the whole interval, you often use the midpoint. the class mark. So for 10-20, the midpoint is 15. For 50-60, it'd be 55.
So it's like a single representative value for everyone in that group.
It gives you a single number to work with for calculations involving that group, yeah.
Okay, so these steps then, you collect the raw numbers, then you tabulate, maybe put it in a table, you figure out the frequency of values, you might sort it, array it,
Right.
and if needed, you group it into these class intervals with limits and marks. That's the core process.
That's the fundamental process for taking that initial overwhelming numerical noise.
Yeah, the chaos.
And turning it into structured information. Information you can actually start to analyze and use for making decisions.
Whether it's student scores or like daily temperature readings or inventory counts.
Anything numerical, really. These are the first essential techniques to get a handle on it.
So wrapping this up then, we've moved from just raw numbers to structured tables. We've talked about frequency, sorting data into arrays, and the whole idea behind grouped data class intervals, class marks.
These fundamental steps are absolutely crucial for making sense of numerical information.
So here's something to think about as we finish. We are surrounded by data constantly, every single day. Now that you recognize these basic structures, collection, tabulation, frequency, grouping, how does that change the way you look at all that information out there in the world?